solve for this one right here, ED. So I'm going to call that one X. I know that X is CD, this whole thing, minus ED, it's what's left over. So if I can come up with an expression for these two, then I've got X. Well, let's see if we can try that. So I know that CD, so this one right here, is opposite angle beta. So CD over here is opposite of angle beta. So I'm going to use something about the tangent to help me figure that one out. I also know that CE, so this one right here, is opposite of this angle, which is beta minus alpha, right? So CE is opposite of beta minus alpha, so just that angle right there. All right, now finding, because both of them are part of this lower triangle, or these things right here, AC is part of both of them. So if I find AC, then I'll be able to use the tangent of some angles to figure out what CE and CD are. So let's come up with that plan. So AC, I'm going to call that H, and now I'm going to start doing some work. I know that the tangent of beta, right? So tangent of beta is going to be opposite of beta, and the opposite of beta is CD over AC. I also know that the tangent of gamma is going to be CD over AC plus 100, right? So opposite, the whole thing, and adjacent, right? So, and the AC is actually H. All right, so I'm going to solve both of these for CD. Okay, solve both of these, excuse me, for CD, and then I'm going to set some things equal to each other. All right. All right, so now I have two things that have a CD in them and an AC, so I'm going to get rid of the CDs and have an AC only. And because I know what beta and gamma are, I'm going to substitute those numbers in, and I'm going to have AC all by itself. So here we go. I'm going to bring the ACs up, right, or the expressions that have an AC in them up there. And now I'm left with CD equals AC, and I'm going to replace this with an H now, okay? So because I've called this H, I'm going to call it H tangent of beta equals H plus 100 tangent gamma. So now guess what? I have H or AC. I have that unknown piece in terms of things that I do know. Now I'm going to distribute this guy so that I can try to get the H all by itself. So here we go. I've got H tan beta equals H tan gamma plus 100 tan gamma. Now I'm going to move this piece to the other side through subtraction and factor out the h's. So I get H tan beta minus H tan gamma, right? And with the h's factored out, I'm left then with just 100 tan gamma on this side. And now divide both sides by this expression here. Okay, so insert a duplicate page here. All right, and oops, looks like I need to grab my tools back. I get H, or AC, equals 100 tan of gamma over tan beta minus tan gamma. Now that I have H is part of both of the CE triangles. Okay. And this one right here. And now if I can get CE and CD, and then I can take the difference and get my X. Alright, so here we go. We're going to try this calculation out. So H equals 100 tangent of 47 over tangent of 54 minus tangent of 47. And go ahead and do that calculation real fast. I'll let you try it. Make sure you're in degree mode. Okay, so the numerator is about 107.23. The denominator tan 54, close parentheses, minus tan 47, close parentheses, 0.304. And if you do that, divide by I get H at 352.73 feet. Now, if that's AC, then AC plus 100 equals BC. And we're back to our triangles here. So this is now 452. I've got this at 47 degrees, which allows me to get the opposite side. That's CD. I've got 352. This is 54 minus 25, so that's that degree right there. That's 352. So now I take the tangent of this one equals the opposite, CE, over adjacent. I got that. And if I take this one minus this one, I get X. Okay, there's a hint. And then what we're going to do is we're going to see that if I have a picture like this, okay, which essentially that's what I've done to my original deal. I had a number here. I had an angle here, I had an angle here, right? And I had a distance down here on the bottom. I'm able to solve for this piece with a nifty little equation that says that height right there equals the change in the position between here and here times the tangent of the top angle divided by tangent of the lower angle minus the tangent of the top angle. Now, that expression right there is going to allow us to then figure out any other combination of triangles. So even if I have a third, another point in here, right, and I got that segment there, or I've got this segment here, as long as I can figure out something on the same side of a known number, then I can figure out all the remaining missing pieces. So, jot this one down, and then we'll be off to the races. Okay, there it is. There is your hint for problem number 3, and I guess you could say beyond, because problem number 3 has other applications as well as just this one with the helicopter and the opening.